There's no graph besides one, and I don't even know what. I haven't read what to do, but we're going to start from beginning.
Okay, well, let's start with the ones you can verbalize.
All right. So the first question has three parts. And it's three different questions in the first one. So the main thing is use the zero product property
Okay,
to solve the quadratic equation below.
okay,
And the first one, A, is 9 equals 3x squared plus 4x minus 6.
okay. When you have a complete quadratic, and by that I mean you have an x squared term, you have an x term, and you have a number, always the way you want to solve it is get everything on one side, let it equal to 0.
All right.
So this 9, I need to move over to the other side. That's going to leave 0 there because I'm going to subtract 9 from both sides. Now I have this. Okay? Now, I can't solve that because it is the addition and subtraction of stuff. If I
Mm-hmm.
could only turn that into one thing multiplied by another, now the zero product rule of algebra says that if you have two things multiplied together that are equal to 0, one of them has to be 0.
Yeah.
So we're going to use the zero product rule to factor this quadratic, and then we'll be able to solve the problem. So
Got it.
this is a hard one to factor. This is going to be one that we're going to use trial and error, but the same first two steps. What's the first step in factoring?
Split 3x squared, put 3x in the left and x on the right.
Next step.
The next step, one second, I'm writing it.
Mhm.
Writing this down, but I'll write it down at the end. The next step is to do on the left, addition and negative due to it being trial and error. And then on the right, we do negative addition.
Okay.
And then we have to figure out what factors of 15 equal 4.
Well, not really. You're definitely talking about factors of 15, but you can throw all those other rules out. They don't have to equal 4. They don't subtract to 4. They don't add to 4. Okay?
Got it.
What we have to do is just try them by a trial and error process and see if we can find a right combination that produces a middle term of plus 4x. Now, which two should I try first?
Uh,
Always the two closest together. Always.
yeah, 5,
Not
3.
to say that that's the right answer, but that's what we're going to try first. Okay? And I'm just going to randomly try 5 there and 3 there. Now, what's our next step?
Our next step is to put it like do the double smile, smiley
Exactly. In other
face.
words, what we're trying to do is figure out our middle term. Does that combination that we wrote produce a proper middle term? Well, what's the inside smiley produce?
5x.
Plus, I would use the plus sign there always.
Okay.
What's the bottom one?
The bottom one is we have to add, right? Just
No,
as a
you're
refresher.
multiplying 3x times minus 3.
Um, it would be -9, -9x.
Okay, you see why we're doing that? In other words, when
Yeah.
the inside smiley is multiplying that times that, the outside smiley is multiplying that times that number, and that number is -3. Okay, add these two together. What do you get?
Add them together, we get negative 4x.
So we didn't do it right. But we got the right number. We just got the wrong sign.
Oh, so we have to switch them around.
Not
And
around,
then,
but the 5 needs to move down to there, and the 3 needs to move down to there. And now when we do the inside, that'll be a negative 5x, that'll be a positive 9x, and we'll have a positive 4x. So in essence, the very first trial we tried produced the answer. So even though I say it's a trial and error process, you can eliminate a lot of things along the way, and you frequently get the answer on your very first trial, especially if you stick with factors that are close together. In other words, you're going to find problems occasionally where 15 and 1 would have been required, but not very often, especially on harder quadratics like this. Okay, so now this is what I have. I have 3x minus 5 times x plus 3 is equal to that. So they want me to solve the equation. What does x have to be equal to?
0.
No?
Oh.
One of these two terms has to be equal to 0. And in fact, when you have a polynomial, just assume both of them have to be equal to 0. Once you get into logarithms, absolute values, radical signs, then they don't both have to be 0, but one always does. But when you're dealing with just a straight quadratic, always solve for both of them. So just set each one equal to 0. So 3x minus 5 equals 0. Solve that.
X equals positive 5?
Thirds.
Oh, positive. Yeah. Oh, I forgot that.
Add 5, and then I'm going to divide by 3. And now solve this one over here. X plus 3 equals 0. What does x equal to?
X equals to negative 3.
There's your two answers.
Yeah.
Based on the zero product rule.
Yeah.
And the zero product rule works regardless of how many things you have. If I tell you that A times B times C times D times E equals 0, by definition, one of those letters has to be 0. You can't find two numbers that multiply together that give you 0. It's impossible unless one of them is 0. It's the only way you can produce a 0.
Yeah.
All right. What else do you got?
The second one is B, and it is 0 equals 3 parentheses x minus 5, and then the end parentheses, and then parentheses 2x plus 3.
Okay. They did the easy work for us here. They factored it already.
Yeah.
So now what can I say?
Now all we have to do is just do like the x minus 5 equals 0, I think.
Which gives you x equals.
Which gives you positive 5.
Okay. What else?
And then it is negative 2x
Not
plus
negative.
3.
It's positive.
Oh, positive 2x plus 3 equals negative 3 over 2.
Well, it's equal to 0 for starters.
Oh, I'm sorry, I'm getting ahead of myself.
It's okay. Okay. Now what about this 3 right here? That can't be 0, right? In other words, we do have 3 things being multiplied together here that are 0, but we know that's not one of them. That's a 3. So if I wanted to, I could divide both sides by 3, get rid of that. 0 divided by 3 is still 0. So this is the same problem as this. In other words, I don't need that 3. It's not going to figure into anything. It might figure in if they said, what was the original function? Now you should multiply it by 3. But basically, this is the problem over here. And these are the two solutions.
All right.
What else?
The next one is c x squared plus 6x equals 0.
When you said C, you meant problem C?
Problem C, yes.
Okay. All right. This is not quite a normal quadratic. What's missing?
We're missing a number on the x,
Okay.
and we're missing the c in the quadratic
That's what we're
formula.
missing is C.
Yeah.
The number, we're not missing a number in front of the x squared. It's 1. Okay. But because we do not have a number added to this, we're not going to start by trying to factor it like we factor quadratics. We're going to consider always greatest common factor. Can you take a greatest common factor out of that? That's always what your first step should be, even on obvious quadratic factoring problems.
I would say 3
No?
is the greatest. Oh.
First of all, a greatest common factor has to divide into both terms evenly. 3 does not divide into x squared.
Oh.
But
I do not know then.
x is the greatest common factor.
Oh. I thought it would have to be a number.
Nope. And notice this is going to answer a lot of things. This now gives us the product of two things equals 0, so we can use the zero product rule. Now, before we go on, let's make sure we factored it right. How do we do that? We multiply these two things back together again. That's x squared. That's plus 6x. We factored it right. Now, what can we say towards getting to a solution? If you have two things multiplied together, it equals 0. Set both of them equal to 0. So what are my answers?
It would be -6 for one of them.
What's the other one?
The other would be -6 too, I think. 0. Oh, because there's nothing for it to do.
Exactly. What our rule says is that either this has to be 0 or this has to be 0. That's what the zero product rule says. So a lot of people want to ignore that x. They do. You can't imagine how many algebra students leave that off. But that is a solution. If x were equal to 0, I would have 0 times whatever is 0. So x being equal to 0 is definitely a solution. Okay. So even though we factored this, we didn't use quadratic factoring, we used greatest common factor, which, like I said, is always the first thing you should look to do. Greatest common factoring will frequently turn a hard quadratic into an easy quadratic. What else we got?
All right. So now we have, for each of the following equations, indicate whether its graph would be a line or parabola.
Okay.
So the first one, A, is 5x plus 2y equals 7.
That is linear.
So it's a line?
Huh?
Oh, yeah.
And I
Okay.
know that instantly because I see 1x, I see 1y, nothing is squared.
So what? So I was about to say, so would B be a parabola then? But you couldn't see B. But so B is y equals 3x squared.
Exactly. The fact that one of the variables is squared makes it quadratic, makes it a parabola. It's either going to look like this or like this.
Yeah.
So
So
you kind of see
then there,
that it all depends on what the power on the x is. Got another one?
okay, we have two more, and it's pretty obvious this may be a line, so it's probably going to be a line. It's C. The C is y equals 3.
You're correct. That is a line. If I do the xy plane, that is a horizontal line at 3.
Because there's like
Oh,
no,
yeah, there's no x, which basically tells you that no matter what x is equal to, y is equal to 3. So when x is equal to minus 10, y is equal to 3. When x is equal to 0, y is equal to 3. When x is equal to 5, y is equal to 3. So y is always equal to 3. That's a horizontal line. If you have x equals 3, that's always a vertical line.
yeah.
Okay?
The next one is D, and D is 4x squared plus 3x equals y plus y, and that is a parabola.
4x squared plus 3x equals
Equals
y plus
y.
y.
No, equals 7 plus y.
Okay. Yeah, and what you want to do is solve these for y. Okay. So I want to get that 7 on the other side, and you're right. That is a parabola. It's not a parabola where I can factor out a greatest common factor. The only way I would be able to solve for the zeros of that would be to set it equal to 0 and see if I could factor it. And it doesn't look like it factors. Oh, yes, it does. 7 times 1 plus 4. Yeah, no, we could factor that one. Does it ask you to, or does it just ask you what type of
It
function?
just it just says indicate whether its graph would be a line or parabola.
Yeah, okay. So the moment we see x squared, we know parabola.
Yeah. So on to the next question. It is a multiple choice question, and it asks which equation below are equivalent to 1/2 parentheses 6x minus 14 parentheses plus 5x equals 2 minus 3x plus 8.
Exactly like that?
Let me double check real quick. So 1/2 6x minus 14 plus 5x equals, yep, that's it.
No,
And then
no
there
parentheses on
are,
the right side.
I'm going to just write. Actually, it's going to be hard to write down, so like type in chat what it is. So the first answer would be
You don't need
like
to
the
tell me the answers. I
oh,
couldn't care less if this is multiple choice or not. This is a
oh,
simple algebra problem. All I have to do is distribute, get rid of parentheses, combine like terms. So let's distribute first. Distribute the half. What do I get? In other words, by distributing the half, I get rid of these parentheses.
oh. I I'm I don't know how to do that. You probably
What is 1/2 times 6x?
It is 3x? I don't know. 1 second. So I don't even know how to do on my calculator, so
Well, I don't want you to do this on your calculator. If you have to use a calculator to do this, you're kind of in trouble. You should be able to multiply 1/2 times 6. And you
so
should be able
but
to
it would be
multiply
3x.
1/2 times -14. Multiplying by 1/2 is the same as dividing by 2. So 6 divided by 2 is 3. What's 14 divided by 2?
7.
So I've removed the first set of parentheses. Now I'm just going to copy everything else like I see it. As long as I'm over here, let's combine the two numbers. What do I combine when I get 2 plus 8?
2 plus 8 equals 8, 9, 10.
All right. Now you have an equation that has a variable x, bunch of them, and a bunch of numbers. So the first thing I got to decide is which side am I going to put my x's on and which side am I going to put my numbers on? Which the best side to put x's on? And your consideration is you want the coefficient to remain positive.
The best side to put the x's on is on the left side, and then the numbers on the right.
Okay, so how many x's do I have if I put them all on the left?
You have all the x's on left. You will have 3 x's on left. So
Add them up. Combine them.
okay, so 3. Yeah, it would be x squared on the left.
No, when you're adding x.
Oh, with the numbers? With the numbers?
When you add, you're adding apples. I got 3 apples and 5 apples. I got 8 apples. I'm not multiplying. If I'm multiplying, then I got x squareds. But I'm
it's 11x.
Okay, that's how many x's I end up on the left side. How many numbers do I end up with on the right side?
You end up with one number on the right side, but there's one on the left, so we have to drag -7.
Well, here's what I mean is you need to move that over to this side. We've already moved this to this side. We got to get all our numbers on the right side. So what is the sum total of the numbers on the right side going to be?
17.
All right. Now we got to solve for x.
All right.
Fraction is fine. You don't reach for your calculator. X is 17 divided by 11.
Oh.
Okay. So is all they really the original question? I mean, you said this was multiple choice, correct?
Yeah.
Is one of your choices 17/11s?
No, it's I was so confused. This may be real confusing. So we have to find a equation in one of the like A, B, C, D like answer things you can circle.
Okay.
Find an equation that equals.
I get it. The problem with verbalizing this is it's just too much to verbalize. You want to take pictures of problems like this? Go ahead and read off A to me.
A is 3x minus 7 plus 5x equals 10 plus minus 3x.
Is that what we got? Right here, in this row right here.
No.
It's exactly what we got.
Oh, what? Wait, 3x plus...
3x minus 7 plus 5x, that's what we got right there. And they just switched the terms over here. That's
okay, I was so confused.
That's the same as 10 minus 3x.
All right.
So this is the answer.
Okay.
Okay.
I was just confused. I'm sorry.
Well, no, I can understand why you were confused because they really weren't looking for you to solve for x. They were looking for you to find one of the multiple choices that matched what you got when you were solving for x. In other words, one of the steps, the very next step after the first one, gave us that answer. Is all we had to do was remove the parentheses, and we had this answer right there.
Mm-hmm.
So we were done after one step. We didn't need to go all the way down and solve it for x. Okay.
Okay. And then we have problems. So then after that, we just have solve for x.
Okay. That same problem?
No, there's 15 problems.
Okay. Got it.
It's just like, it's like x squared minus.
Go ahead. These you can verbalize pretty good.
Yeah, these I can verbalize well. So the first one is x squared minus x minus 12 equals 0.
Okay. That's the second time I've heard you say minus twice in a row.
Yeah, it's 2 minus.
You meant it. I think you only meant one minus, correct?
No, there's 2 minuses. It's x squared minus x minus 12.
I heard you say minus twice, but I thought I heard you say minus twice on the other problem also.
Oh, no. I'm sorry. Sorry, there's no negative 12. I'm sorry.
So it is just...
It's just 2. It's like, yeah, it's that. I'm sorry.
Well, let me tell you a funny little story. The biggest problem I have, I've tutored algebra for 10 years. The biggest problem students make is they drop negative signs. You're the only student I have ever had that's added negative signs. I kid you not. I kid you not. Most students hate negative signs so much that if you got 2 negative signs in a row, they'll throw away one of them just to get rid of one of them. Unfortunately, it gives them the wrong answer every time. You cannot drop negative signs. If something is negative, just write it in there. It's negative. Okay? So, I'm just going to cross that one out because that's not the one we're dealing with. Now, this is a normal looking quadratic, correct?
Yeah, I actually think I just know the answer by looking at it.
Okay, what is it?
Negative 12.
No.
Oh.
Let's go through factoring. You can never get too much practice factoring. What's the second step of factoring?
We have to split the x's.
That's the first step. I've done that already.
Oh, second step is to determine the sign, and the sign is going to be minus due to the middle term.
You got to determine both signs.
Oh, they're both minus.
No, if they were both minus, that wouldn't be a minus 12. Because remember the last step of FOIL. The last step of FOIL is where you multiply that number times that number. So if they were both minus, you would have to have a positive number there. If they were both plus, you would have to have a positive number there. Because we have a negative number there, then one has to be plus, one has to be minus. Always. If you have a minus constant, then one has to be plus, one has to be minus, and I only write it once because the coefficient of each x is 1. So as long as the coefficient of each x is the same, then plus minus is the same as minus plus, and I don't have to write the plus minus on each side. Okay? Now, third step, fairly straightforward. Better if you can verbalize it, because I know if you can verbalize it to me, you'll remember it more.
Okay.
What are we looking for?
We have to look for factors that equal...
Factors of 12.
Factors of 12 that equal...
Not that equal, but
that add to...
Not that add. Do whatever that sign says.
Subtract.
To what?
X.
No, to the coefficient in front of x.
Oh, 1?
1, exactly.
Oh,
So let's
okay.
look at our factors of 12. Cut that in half, double that, cut that in half, double that. There's two factors that subtract to the number 1. And we're not really looking to subtract the minus 1. We're looking to subtract whatever the absolute value of that number is, 1. Well, I got them, 4 and 3. Now my last decision, step 4, is put the larger of the two factors on the sign of the middle term. Sign of the middle term is negative. Where do my factors go?
Oh, so 4 goes on the negative and 3 goes on the positive.
Okay. Since that is true, what are my solutions for x?
Solutions for,
Zero product property.
okay. Your solutions for x is x plus 3, the x equals negative 3.
What else?
1 second, equals negative 3. And then the x minus 4 equals 0, the x equals positive 4.
And there's your two solutions. And you usually have two solutions when you factor a quadratic. You almost always have two different solutions. Occasionally you'll have just one solution. But most of the time you always have two solutions. All right,
Yes.
looks like we're going to get some practice factoring here, which is good. You can always use practice factoring. What's the next one?
The next one is 3x squared minus 7x minus 6 equals 0.
Okay. Again, given to us in perfectly standard format. In other words, I've got the entire quadratic on one side, I got 0 on the other. So always assume, or at least give it a shot to see if you can factor it. Now, all of these aren't going to be factorable. If they're not factorable, you have to go to the quadratic formula. But the quadratic formula is long and complicated and a lot of arithmetic, so it's worth a shot factoring it. First step.
We split the 3x squared, put 3x in the left and x in the right.
Second step.
Second step is to determine the sign, and due to seeing
Plural signs, both.
sign, to determine the signs by looking at the x, the 6 and the middle term.
Don't worry about the middle term yet. Let's just focus on this for starters. So what does that tell you the signs have to be?
One has to be positive and one has to be negative.
So it's either plus minus, but because these coefficients for the x are different, I have to consider minus plus also. Okay?
Okay.
Now, I know that I'm going to look for factors of 6, so let's just start listing the factors of 6. That's all I got. What do I tell you to do? Always try the two factors that are what?
Closer together.
I'm going to try these randomly. I'm just going to automatically start with 3 and 2 and see if we can produce that middle term. Well, what does that give us for a middle term?
That gives us positive 3x. Long term is negative 6x.
Is that our middle term?
No, it's not.
Okay. Not only is it not our middle term, it doesn't have the right number. So dropping the 3 down to the negative sign and the 2 down to the positive sign, it's just going to turn that into a plus 3x. So I don't even have to try that one. Okay. Well, the next best combination is to switch the 3 and the 2. So I'm going to put a 2 there, and I'm going to put the 3 over here. Let's see what that produces. As a middle term, that would give me, this gets a little crowded. That would give me 2x there, minus 9x there. Bingo, minus 7x. Had that turned out to be plus 7x, then I would have dropped the 2 down to the minus sign, the 3 down to the plus sign, and I would have had the answer. But I still, even though this is a relatively hard problem, I was able to do it with just 2 trials. And my answer is, just to be clear, 3x plus 2 times x minus 3. If I do that multiplication, I will get that. Now, if I set that equal to 0, solve it for x.
Oh, are we doing roots now?
No, you're still using the zero product rule.
All right. We are.
In other words, I have this thing over here multiplied by that thing over there.
We're doing what, like the x equals for each parentheses?
We're going to solve for x. The instructions
Okay.
solve for x. We haven't solved for x yet. Because all we've done is factored it.
Okay, so the first one will be negative 2/3.
Good.
Equals 0. 1 second, let me write this down. Negative 2/3. And then the second one will equal positive 3.
Okay. What if I had an x out here in front? What's the third solution?
The third solution would be 0.
Correct. In other words, it doesn't matter how many things you have multiplied together. If all of them multiply to 0, then each one of them is equal to 0. And then solve for x. Okay. I feel like you're getting the hang of this pretty good.
Mm-hmm.
I don't know how many more types of problems you have. We have 15 minutes to go. If you want to jump around to ones you're not so sure about, we can do that. If you want to do another 1 or 2 like this, just to tell yourself that you know how to do them for sure, that's fine also.
Okay. Let's do number 9. And 9 is 6x squared minus x minus 15 equals 0.
Okay. Can I take a greatest common factor out of it?
The greatest common factor would be, yes, you can, but the greatest common factor would be x, I believe.
No, you can't divide 15 by x. In other words, remember what the definition of greatest common factor is. You have to be able to divide every term you see by that factor evenly. Okay, it looks like 3 could be, because 3 will divide into 6 and 3 will divide into 15, but 3 won't divide into 1. So the answer is no, there is no greatest common factor. Furthermore, they've made this a pretty difficult problem because there are multiple factors of 6. In other words, the very first step is not automatic. It could be 6x times 6. It could be 3x times 2x. What do you suppose we should start with?
3x times 2x.
Always. And the only reason I say that is because most of the problems they give you in Colorado, the answer ends up being the factors that are closest together. Okay?
Yeah.
Second step.
Second step is to determine the signs.
Which are?
By looking at it, it's going to be positive and negative, so trial and error in a way.
And now let's look at factors of 15, because we've got a couple of those also. I guess that's all there are. Which ones should we try?
3 plus 5, 3, 5, 5, 3.
Okay, I'm just going to try it like this. Now, real quickly in my head, I see that 5 times 2 is 10, and minus 3 times 3 is minus 9. That does add or subtract to that coefficient, which is 1. It's just not written. Okay, so to be sure, let's do the smiley faces.
Yep. 1 second.
9x. That's minus 9x. Ah, that's plus 1x. That isn't correct. What do I have to do to make it correct?
Switch them to get the, switch the signs
Switch
to get
the
the
signs. When you say switch them, I think you want me to put the 3 where the 5 is and the 5 where the 3 is. What you really mean is change the signs on the numbers. So move the 5 down to there. Move the 3 down to the positive sign. And now this will be a minus 10x. That'll be a plus 9x. Add them together, I get my minus 1x, and that is my middle term. I have my answer, 3x minus 5 times 2x plus 3. I don't quite have the answer yet. What are my two answers?
your two answers. The first one is going to be positive 5/3. And then your second answer is going to be, what is it? Second answer is going to be negative 3 halves, 3 seconds.
Good. 3 halves is correct.
Okay.
Now, what if I would have tried all combinations? In other words, I try all combinations of 5 and 3, and I can't produce the middle term. My next step would probably be to try all combinations of 15 and 1. And then if that didn't produce the middle term, I would go back and resplit that into 6x and x and start the whole process over again. In other words, these type quadratics can be extremely difficult if there are lots of factors. In other words, if they give us numbers that have lots of factors, if that would have been a 12, well, 12 has a lot more factors than 15 does. 12 is 12 and 1, 6 and 2, 3 and 4. They already made the problem difficult by giving us multiple factors for that first term. That's unusual. That's the first one we've seen, where there were more than one way to split up the x squared term. Okay, let's have another hard one like that. You're good at the easy ones now.
Yeah. Another hard one would be I'm actually trying to find a. Actually,
That's a good
this
sign.
may.
When you have trouble finding a hard one, that's an excellent sign.
Yeah. This actually may be a hard one, but maybe actually really simple. It is x squared x squared minus 12x equals 28.
Okay. Well, the first thing I'm going to do is put it in standard format. So tell me what I need to do to get it in standard format.
I don't know. Oh, don't we do parentheses?
One side is 0. Everything else is on the other side.
So we would have to like subtract 28 and put it on the left. Yeah, negative 28. Okay.
In standard format. Now we're ready to factor.
Okay.
And this is not a hard one. It's relatively easy. The x is only split up one way. Second step.
Second step is to determine the signs.
Okay, tell me what they both are.
They are both positive and negative, trial and error.
No. First of all, if the coefficient on the x is the same, even if it's not 1, let's say it was 2x and 2x, then if you determine the signs of the opposite, you only need plus minus. You don't need the plus minus on each one. In other words, this is exactly the same as this. So I don't need to consider this one.
So no matter what way.
Yeah, the only time you need plus minus on each one is if the coefficient of the x terms are different. On the last one of them was 3x and the other was 2x. That's different coefficients. Then you got to allow for plus minus on each side. This one we do not. We're just going to go with a plus and a minus. Now this one is actually quite simple. What's the third rule? Verbalize it.
Third rule is to find factors of 28.
That do what?
That equal 12.
You keep making that same mistake. They don't equal 12. They what?
They
subtract
to 12. Okay.
12. Well,
so if there's
that's
a negative if there's a negative in front of the third term, we have to say subtract.
Yes, exactly.
Okay.
In other words, not only does that negative mean that the signs have to be opposite, but it also means that the factors of 28 have to subtract the 12. Well, here I'm going to list factors of 28. I just found the ones that subtract the 12. Which are they?
14 and 2.
Where's the 14 go? Where's the 2 go?
14 goes on the positive, 2 goes on the negative.
A bigger factor goes on the sign of the middle term.
Oh, I forgot the middle term, so it's negative.
Goes there, the 2 goes there. And now if we were to do the double smiley face, we don't really need to because it's so easy. But that's going to be plus 2x minus 14x. Add them together, you get minus 12x. That is our middle term.
Yeah.
Okay. And then your solutions, of course, are x equals minus 2 and x equals 14.
All right.
Okay.
Yep.
What else you got? We have time for one more.
One more. Can you scroll back up so I can look at the roots real quick again?
Yeah.
X equals negative 2 and x equals 14. Okay.
Yeah,
the next one.
X, then the answer is always the opposite sign of that and the opposite sign of that. But that's only if it's an x. If there's like a 2x there, then that one's not equal to 14. It's equal to 7. But if you're just looking at x and x, just take that, change the sign, and those are your answers.
Okay. This may take a bit, but yes, there's one more that I'm a little confused on. It is number 13, and it is 2 plus 9x equals 5x squared.
Okay. We see an x squared term, we see an x term, and we see a number. So how do I want to arrange this?
You want to put in basic format, I think it's called.
Okay, standard format. So tell me what that is.
We're probably going to have to subtract 5x squared from
Actually, you want basic format to have a positive coefficient. It's very difficult to factor negative coefficients. So I'm not going to move the 5x squared to the left. I'm going to move the other two to the right.
All right.
And what that does is preserves that positive coefficient, which is going to make this easier to factor. Okay. Right. When these are negative numbers, it is really difficult. You always want to change it to a positive number. If it was a negative number, just divide everything by minus 1 and you'll turn it positive. Okay? So,
yep.
First step
is to split 5x squared, 5x on the left, and x on the right.
Okay, second step,
is to determine the signs,
which are
and which are, I
opposite.
believe,
Opposite is the
opposite.
answer. The signs have to be opposite. Okay, now that I know they're opposite, it's either plus minus, but it might be minus plus. But I know they're opposite, otherwise I could not produce this negative 2. Okay, how many factors of 2 are there?
2.
Just one.
Oh, 1. Yeah.
2 and 1, that's it. So I don't even have a lot of trial and error here. And I can see that that's a pretty big number. So my 2 better multiply that 5, right? So instead
Yeah.
of starting right out writing 2 and 1, I'm going to put the 2 over there and put the 1 there. Because I can tell that's going to give me the correct number in the middle. In other words, sometimes you can get a little bit ahead of yourself and tell and eliminate some of your trials and errors. I know that if I put the 2 on the left and the 1 on the right, I don't get anywhere near 9. To get to 9, I got to have the 2 multiplying the 5. And in fact, that is the correct answer. Gives you minus 9x.
Yeah.
So the answer is 5x plus 1 times x minus 2 equals 0. What are the two answers?
The two answers is the first one is negative 1/5.
Okay.
Negative 1/5. The second one is, what is the second? The second one is positive 2.
There you go. That's all there is.
Mm-hmm.
I think you get it.
Yes.
All right. Josh, I will talk to you next time. Before you go, let me just make sure that I've got it scheduled right. I've got you scheduled for Sunday night at 6. Is that correct?
Yes.
Okay. I'll see you then.
All right. See you.